The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to the H2USA Station Analysis Tools webinar. My name is Chris Worth, and I am the organizer for this meeting. We'll begin shortly, but first I have a few housekeeping items to tell you about. Today's webinar is being recorded, and the recording, along with the slides, will be posted to our website in about 10 days. We will send out an email to attendees once those are posted to the site. All attendees will be on mute throughout the webinar, so please submit your questions via the question box that you should see on your webinar panel. We will cover those questions during the Q&A at the end of the presentation. Since we have multiple speakers today, please indicate who your question is for when submitting your question. With that, I would like to introduce our DOE host, Fred Josic, joining us from Washington, D.C. Fred is the lead Systems Analysis Project Manager in the Fuel Cell Technologies Office. Good afternoon, Fred.
Thank you, Chris, and welcome everybody to the webinar, and good morning. Today, the webinar is intended to give you insight into two tools for analysis of infrastructure. The tools you're going to hear about today are H2SAM, H2FAST and HRSAM, and they were developed in support of H2USA. First, we'll talk about HRSAM, which is a hydrogen refueling station analysis model. And second will be H2FAST, which is a hydrogen financial analysis scenario tool. And we'll go through the presentations, and then we'll answer questions that have been submitted. So with that, the first speaker will be Dr. Amgad Al-Gawani from Argonne National Laboratory that leads the life cycle analysis team at Argonne. His research focuses on evaluating energy and environmental impacts of advanced vehicle technologies and infrastructure needs of hydrogen delivery and refueling. And Amgad will be talking about the HRSAM. Amgad?
Thank you, Fred, and good morning, everyone. Today I will present the hydrogen refueling station analysis model, and abbreviated as HRSAM, which was developed in support of the H2USA, as Fred mentioned, in particular supporting the hydrogen fueling station working group within the H2USA. It is a near-term hydrogen station cost model, and it is different from the modeling activities we did for DOE in the past, which had a different objective. So today I will present HRSAM. Next slide, please. So before I start, I would like to acknowledge those who contributed to the model development. And here you see several names, Daryl Brown, Nihar, Stagi, Joe Pratt, and Danny all provided data, input data, and the critical reviews. George Parks, Bob Boyd did go inside out the model and provided critical reviews, and of course Lance is the lead of the hydrogen fueling station working group, has been providing guidance, and Erica Sutherland from DOE, she put the team together and provided overall direction and the guidance. So with that, I go to the next slide, please. So the objective of this tool is to understand the major drivers, cost drivers at hydrogen refueling stations. And the goal here is to lower the contribution of hydrogen refueling stations to the dispense cost of hydrogen to customers. And with doing so, it would promote the adoption of hydrogen fuel cell vehicles. As you see in this slide, the hydrogen station is capital intensive, and to understand the cost drivers, we need to model the details of the component and the sizing of the component with different delivery methods, looking at the impact of several parameters. And this is really what was done by Joe Pratt and Danny, among others, in the H2FAST hydrogen reference station design task that you see at the bottom right of the slide. This report is a very comprehensive report, and it is available at the DOE website for your reference. So that project did exercise this very tool to examine different station configuration and try to evaluate the cost drivers and come to some conclusions and some pointers about how to lower the hydrogen cost at refueling stations. Next, please. So a background, HRSAM is meant to be a user-friendly tool. It is available on public website, DOE website that is downloadable. It is kind of allowing the user to define certain key parameters of the station and then evaluate. So it is built from scratch. However, it is really based on a refueling module inside another model developed at Argonne known as HDSAM for hydrogen delivery scenario analysis model. So we did really look at refueling station extensively over the past 10 years. However, we wanted to look at a model which is populated with early market cost and design practices, and also to examine certain features that we didn't examine before, such as the impact of utilization ramp up that is consistent with an existing network of stations and a deployment rate of hydrogen vehicles. So we gathered component cost and performance data from vendors and industry contexts. The model does optimize and size the components and observe certain features of the fueling protocols recent 2601. And as I mentioned, the model has been reviewed by peer reviewers and experts from the industry. The cost data were recently compared against some of the cost numbers, for example, in the CEC recent ponds, and this was done by Daryl Brown from PNNL. Next slide, please. Yeah, I should mention it is really Excel-based tool. It is user-friendly, fully transparent. From the input, you can track all the way to the outputs and be able to understand the logic and see how the model itself works. So it is fully transparent, user-friendly, Excel-based tool. So what are the model inputs? What are the key inputs that we were after trying to understand their impact? So first, design parameters. For example, station size is really a big factor. Station utilization, I mentioned really. So what if the vehicle's deployment rates are slow actually? How does that impact the economics at the station and the bottom line costs of hydrogen? Several design configurations that is related how hydrogen is being delivered. A station that receives liquid hydrogen in liquid form is very different than a station that receives hydrogen in gaseous form. And if it receives in gaseous form, whether it receives it at a low pressure or a high pressure in tube trailer, these will all have some implications for the capital required at the station to satisfy certain refueling requirements. And then some performance metrics, for example, how many back-to-backs or how many kilograms in a minute, and all of these have some implications on sizing the components. Economic parameters, for example, the rate of return, which is also the discount rate that is used in discounted cash flow analysis to determine the present value of future cash flows. The project period, or here it is called the analysis period, whether you are looking at a project that will last 10 years or 15 years, they make a big difference. Debt to equity ratio, component life, depreciation schedule, how often you will replace the component is important. And there are other important parameters, even though not related to capital. For example, the setback distances, liquid versus gaseous, could make a big impact on the cost and even the availability of land for installing the equipment. Reliability of the component is another factor that the model can handle. So in early market, if there is a component that requires more frequent replacement, you could input that into the model, and then the model will give you what is the implication of that. And finally, the efficiency of the equipment, for example, how many kilowatt hours for compressor or for free cooling. although it is typically small, it could be significant in early market. For example, cooling energy. If you spread the cooling energy over a few kilograms filled a day, it will be very different from a station that will operate with at its full utilization. So all of these the model can give insight to. So what are the methodology? Typically, we start from the left here. So you start with some market definition. So the user will specify, I am looking at a station that is 100 or 200 kilograms a day. Then they will define certain parameters for performance, how many back-to-back, how many kilograms, and so on. Is it a T40 station? Is it a T20 station? And then the utilization scenario. So over the project period in 10 years, how many vehicles will come on the average the first year and the ramp up in the second year, third year, all the way through full utilization. And then the user will specify whether the station will receive hydrogen in gaseous form or in liquid form, or perhaps from some on-site production, and even few stations may receive through a pipeline. Then based on these, the model will start to select the component consistent with the delivery method, whether it is gaseous or liquid, and then start to size the components. And then based on the financial and economic inputs and the cost of components, then the model will optimize the sizing of these components. And then finally, the model will give some high-level dollars per kilogram, but can give more details on capital, operating, and energy cost. It will provide the cash flow, both annual and cumulative, and then it will give other information, for example, the land area requirement, the annual energy cost, the annual operation and maintenance cost, and so on. And as I mentioned, the model is available in public domain at the DOE website, and the link to the model is provided at the bottom of this page. So how did we populate the model? I mentioned that we went after major components, trying to talk to vendors, understand the cost actually of the components today, uninstalled and installation cost and all of that. And here you will see small compressors on the top left, larger compressors on the top right. You will see the pre-cooling equipment in the bottom left. You will see the hydrogen storage, and these are just the selected examples. And you will see the data points we collected. It is, of course, aggregated so that there is no attribution to a source, but these are actual data received from different vendors, and we were able to develop some cost function because we cannot rely on a single data point. We need a cost function that will, based on the size of the component and based on the design parameter, whether it is small station, large station, and the performance metrics, we need really to intercept a cost formula to arrive at a cost for each component. Next, please. So then the model, after selecting the component, go through some optimization to arrive at if this station is optimized to minimize the cost of hydrogen, given some demand profile, which is a surrogate here. The top figure here is a surrogate for how many back-to-back during peak hours. Then the model will start to look at different combinations of buffer storage size, compressor size, and how it will satisfy eventually the refueling requirement during peak hour at the proper fill rate, and considering a back-to-back specified by the user, and then arrive at a minimum cost, and this will be the size that for the component that will project the cost for. Next, please. So what will the model give as an output? So this is just a rehearse of what we had before. $1 per kilogram is the bottom line. What is the total capital investment? What is the operation, annual operation and maintenance, and the energy cost? Cash flows, time to break even. Even the model will give what is the contribution of different components to the bottom line dollars per kilogram. For example, if the compressor contributes $1 or $2 of the total cost, dollars per kilogram, or how about the pre-cooling, and so on. So the model will be able to give that level of detail so that we will see the major cost drivers at the station, and this could be an area that researchers may go after and trying to look at solutions, how to reduce the impact of that specific parameter or component. Next, please. So we identified several factors. Of course, one of them is the economies of scale of the station. A small station will result typically in a high dollars per kilogram, while a larger station will result in otherwise. So we did really some runs just to provide some insights that the model can provide. The supply form, whether you supply in liquid or in gaseous form, this has some impact. And the performance of the station, how many back-to-backs actually is another factor. And then the utilization is the biggest of all, and we reserve this to the last. So next slide, please. So here we look at liquid deliveries. Liquid delivery is very favorable. I mean, it is delivered kind of at a minimum cost compared to other forms, because you have a very high payload and you can deliver larger quantities one at a time. It is also in a very condensed, compact form, and that the refueling station doesn't need to do a lot of packaging. However, in early market with less frequent fueling, there is significant boil off, and the boil off could be in the order of 50, 60 kilograms a day. So if you dispense a few kilograms and then you lose 50 or 60, then it is a major implication. So liquid stations, actually in early market, we see some designs that will really opt to use the boil off, put it in a buffer storage, and even use some pre-cooling actually to dispense into vehicles. Of course, this is more capital, but it is really a trade-off between losing a valuable molecule versus really putting more capital on site. And here you will see the trade-off, and you will see a certain demand level in a given day, the impact of the. Then you will see there is actually at some point liquid pumping, the small capital impact of boil off will be less, than the configuration of the station could be very different from the early stations. Next slide, please. This slide we show the impact of delivering hydrogen at a compressed form in tube trailer versus delivering hydrogen from on-site production or via other means at a low pressure, and you see that factor by itself is significant. You see tube trailers can play a role in early markets. However, because they are limited in capacities, then a station can only receive tube trailers only if the payload is greater than the station capacity. So as the station capacity grows into the future, then tube trailers may have a limited role. Funding for type 3, type 4, the tube trailers, understanding really how the lightweight tubes could carry more payload. Now we see tube trailers can carry up to 1,000 kilograms payload at 500 bar. Next slide, please. So station capacity, of course, larger stations will require more capital and therefore are more expensive. However, if you look at the dollars per kilogram, if you click next, please. So if you look at the contribution of that capital into the kilogram dispensed, actually this is a much smaller. So you see the impact of the economies of scale is very significant. In early market, though, you cannot afford a very large station. You need the network distribution, and because the demand is not there, then you will be at the left side of this graph. Maybe smaller stations, high dollars per kilogram, but as the market develops, then as you move to larger stations, then the cost contribution of the station to the dispense cost of hydrogen will be much smaller. And I have one more slide. So here we'd like to look at the utilization. I mean, here we show two examples of utilization. You will see the top line. This is a station that is kind of utilized at its capacity from the first day. This is the blue line. About 80% of the full capacity will be utilized from first year. However, we know that stations will be deployed first, vehicle will come next, and then the deployment rate will impact how you ramp up the utilization of the stations. Of course, the more you sell, the better your bottom line, and then you could really spread your capital and depreciate your equipment over a large amount being sold over the project period, and therefore the impact in the cost of hydrogen could be dramatic. And the takeaway message here is that deployment rate of vehicles is very critical to market success. Refueling station costs are not trivial, And the only way really to improve your bottom line and to be able to end up with being able to deploy larger stations, improve the utilization, which will impact the hydrogen cost, which is a positive feedback cycle that will enable more fuel cell vehicles. So you will see really, you could go either in a positive feedback cycle or a negative feedback cycle. So the key message here is that the deployment rate, how fast the vehicle will come, will impact really how the infrastructure may develop and the success, market success for fuel cell vehicles. So with that, just to conclude, I would like to thank you for listening. I put a link here to the model and in fact to the H2USA model, and I turn it back to Fred.
Well, thank you, Amgad. So we'll go to the next presentation, and Dr. Mark Molina of the National Renewable Energy Laboratory, who is the team lead for the Infrastructure Systems Analysis group at NREL, will be presenting for, his focus is on research on early market dynamics and the scenario analysis for hydrogen infrastructure development and fuel cell electric vehicle deployment. And he's going to be talking about the H2 FAST tool, which, as I mentioned before, stands for Hydrogen Financial Analysis Scenario Tool. So with that, Mark?
Great. Thank you, Fred. So I'm going to go through these slides, and I just want to acknowledge up front my colleagues Brian Bush and Michael Pennow for their significant contributions to the H2 FAST modeling framework. You can go to the next slide. Just a quick overview of what we're going to present. A couple introduction slides. What is H2 FAST? What questions can it answer? And then in turn, we're going to go through each of the different versions of H2 FAST, a web-based version, an Excel-based version, and then a beta version that is not yet released to the public, but it's in the works, that we call the business case scenario tool, and then a final summary slide. So just an overview of these three different versions of H2 FAST. First off, the actual financial calculations are identical between each of the different versions. And the reason why we have different versions is that the interface is designed to meet the needs of particular end user groups. So for example, the web-based version of H2 FAST is intended to be very simple, easy to use, online calculator to provide fast turnaround responses to relatively simple questions about financing a hydrogen station. The Excel-based version of H2 FAST allows for more control by the end user on inputs, a wider range of inputs, and then more elaborate exploration of outputs. And then finally, the business case scenario tool explores an even broader range of outputs from our SARA model, which I'll talk about later. Go next. So here's some examples of different questions that can be addressed by each of these different versions of H2 FAST. For the web-based tool, you might have a hydrogen station project and you're interested in how capital incentive would change the financing. So if there's $1 million capital incentive, you can quickly see how that influences the financing for your station project. Similarly, if you have some additional revenue from retail business or some other part of the business that you're going to allocate to the hydrogen station, say $10,000 per year, you can add that and see how that influences the finances for that project. In general, once you've explored the web-based version and you feel like you have more detailed questions, you have more information that you want to plug into the financial analysis, you can switch to the Excel-based version of H2 FAST. For example, if you have more information on your demand ramp-up rate, which God did a great job emphasizing how important that is for costs and for financing. If you had a sluggish first couple years, but then you're anticipating a rapid growth in a particular year, such as a fourth year, you can control those inputs in greater detail in the Excel version of H2 FAST. Similarly, if you have more information on multiple stations, you can put up to 10 stations into the Excel version, and say you're providing $5 million to a set of different stations for a multi-station project, you can evaluate the finances of that situation. Finally, the acronym here is Business Case Scenario VIS. VIS is visualization. A more elaborate, broader range of types of questions can be addressed, such as investments and incentives for a broader network of stations over a longer time frame for an entire metropolitan area or a different region of the country. Similarly, that type of scenario, you can try and explore how to prioritize investments between regions or between cities. Let's go to the next slide. So we're going to start going through the web-based tool here. This is just an overview of the interface for the web version of H2Fast. So you can see on the left, we have the grade area where you have the inputs, different rows. There are information icons, the little blue circles. If you hover over those with your cursor, it'll bring up a description of each of those items. Those are all the inputs for costs and for the station configuration. Then you can see the cells where you can enter values directly by typing them in. And then to the right of that, within the gray box, are sliders, so you can quickly change those values to explore the results. All of the outputs are on the right-hand side of the panel. At the top on the right are some of the key results that we had feedback were most important to financing a hydrogen station, such as internal rate of return or payback time, net present value. So those are the single value results. Below those, there are two graphical outputs. And as those blue arrows indicate, those point to the tiles across the top, which are actually drop-down menus. So these two examples are net income and then cumulative cash flow on the bottom, or net cash flow and then cumulative cash flow. If you pick on those drop-down menus, you can choose from a broader range of time series metrics to change those visualizations on the right-hand side. And then as you can see, these arrows are pointing to other parts of the interface. In addition to those drop-down menus, if you want to go back to the original default values, which are taken from HRSAM, you can click on the Reset Inputs button. If you want to download detailed financial statements, you can click on the CSV button on the bottom right, and you can get an Excel file, sort of a data dump for that particular scenario that you've set up with the inputs. Then on the top right, there are two different buttons. One will give you a download of the spreadsheet version, which we'll talk about in a bit. And then the other one allows you to embed H2Fast, this web version, on your own website. So right now we have this running on an NREL website and also on an H2USA website. So before we go into a couple examples, if we can go back one slide. A couple caveats here. This is not a cost estimation tool, which HRSAM is. The users here is assumed they have some background information on a particular station project, and they know sort of realistic values to plug in, and then the results, the financial results, will be more meaningful. If you start changing these in a very theoretical way without having a consistent set of cost inputs, the results will not be as meaningful. Also, if you click on the About button, which is in sort of the top center there, it'll bring you to the user manuals and some links to some of the reports, such as the reference station report God mentioned, and some other resources as background on hydrogen station costs. Okay, so now we have a couple examples. So this first case, the example inputs are shown in the bullets on the left. This is for a 1.2 million station. Click one more time, you can see where we put these inputs. There's capital and installed costs, adding up to 1.2 million. And then here we're assuming that the cost of the hydrogen delivered to the station in a gaseous tank truck is $5.5 per kilogram, and we're selling it to vehicles at the pump, the price of the pump, for $14 per kilogram. If those are our inputs, the values on the right, the graphs and the single value results at the top are our results. And for this particular set, we would have a 15% internal rate of return and an 8-year investor payback. So that's example case A. If we go to the next slide, we're going to do a variation on the same station. We click one more time, we see those same values, but now we're adding a $1 million capital incentive, which is going to change the finances significantly. We're assuming that we can now sell the hydrogen vehicles at $10 per kilogram, but even at that lower price to vehicles, our internal rate of return increases to 19.5, and the investor payback time period goes to 6 years. So as you can see, this can be done very quickly in the web-based tool, and you can explore these variations around a particular station. If we go to one more case, we're going to take that same station, same general inputs, but we're going to add one more item here, and that's the incidental revenue. We're saying that there's $10,000 per year from the business that we're going to allocate to the hydrogen, and so that further improves our finances. Now the internal rate of return is 22%, and the investor payback time is 5 years. So those are 3 quick examples of how to use the web-based version of H2Fast. So now we're going to move on to the next version, which is the Excel version. So again, the idea of the Excel version is you've used the online calculator, you have more information that you want to plug in to do more detailed financial analysis. So the Excel version gives the end user greater control of the inputs and provides more details on the outputs. Another item before I get into the bullets here is really the Excel environment might be more comfortable for a lot of different analysts and allows you to do a lot of the functions in Excel that you would do with a normal Excel spreadsheet. For example, people who are familiar with goal-seek, you can run goal-seek in the H2Fast version to get very detailed results on particular trade-offs between parameters. As I mentioned earlier, this first bullet here, you can do 1 station, or you can do up to 10 stations. You can look at the finances individually or for the whole cluster of stations that you've set up. This allows you to do side-by-side comparisons between different station projects, real or hypothetical. And then to make the model more user-friendly, there's 2 different modes of interaction for the user interface. There's the basic mode, where you have 20 parameters, or you can switch to the advanced mode, which gives you access to even more input parameters, 51 parameters. Each of these different parameters has hover-over descriptions so that you can understand them more quickly, and then there's also the user manual. For the outputs, they're similar to the web-based version, scenario parameters, and then full financial statements, income statement, cash flow, balance sheet, and then quite a few different financial ratios. Go to the next slide. This is a screenshot of the full advanced mode of the user interface. So we're going to zoom in on some of these in a second, but just so people can see, or we can zoom in right now. Okay, thank you. We have color-coded these. So this is the expanded view. If you move to the basic view, you would just see the light yellow cells, and all the orange cells would disappear. So it'd be a simpler user interface, and that would probably satisfy a lot of end users. If they want to move to the advanced one, it's easy to do that. So let's zoom in to one of these areas. This particular part of the user interface just shows the cost and incentive inputs for each of the stations you've done. You can use this for 1 station, but then you can add up to 10, and this just allows you to quickly see the differences between the cost inputs and the incentive inputs between all the stations that you've put in. Go to the next portion of the user interface. These are some of the key toggles. So on the left, those blue buttons are reorients the user interface between the basic mode, which is the first button, and then the advanced mode, so you can switch between the 2 easily. On the right, those 2 blue arrows let you switch between each of the different stations that you've entered into the model, and so it pulls up the results for each of the stations as you toggle between them. If we go to the next part of the user interface, this is the detailed list of inputs. This we assume satisfies the needs for most people looking at a realistic hydrogen station project or multiple sets of projects. And that advanced mode, again, is all the orange cells. And those can be applied consistently across multiple station types to look at the finances across multiple stations. So a lot of control here on the different input assumptions. If we go to the next, at the very top, we have, just like in the web-based version, sort of the main parameters that we found and our reviewers found to be most important for financial end users. So internal rate of return, payback, positive earnings, net present value, and a break-even price of hydrogen for a 10% IRR. Go to the next, we have this graphical user interface, which is a time series of a particular metric. And if we click one more time, we can see that the user can change the graph in terms of what time series metric is shown. So if we click one more time, this particular box shows which metric you've pulled up, and the drop-down menu gives you the full list of 65 different metrics, and the green box gives you a description. If we click one more time, a description there of the particular metric you're looking at. So finally, this is just a quick visual and some of the key numbers for a cost breakdown. So the blue bars at the top of this section show the revenue breakdown, so this could include incentives or just sales. And then the orange bars show the breakdown of the cost, built up of the cost for the station that you're evaluating. So that's a quick run through of the user interface for the Excel version. A couple more things we can highlight. The next slide just shows a different tab. This is the full financial statements for the particular station you have pulled up. And so in an Excel version, you can copy and paste this, and you can see these values very readily. If we go to the next slide, just demonstrates the graphs for those time series. And you can see that you have access to a lot of different metrics over time. So if you want to pull up one of these and explore how it changes over time, you can just leave the model on one, and then you can switch to another one very easily. Okay, I think those are all of our slides. If we click one more time, we should be able to get past this one, and we can start talking about the business case scenario tool. So this is the third version of H2Fast. This one is not deployed to the public, but it's being used internally, and we're exploring how we might make it accessible to the public. Just as background, this is a multivariate visualization tool, and the idea is to provide access to a large set of scenario results for an end user. And in this case, the tool that's being used to generate those scenario results is the SARA model, which is NREL's cost optimization model, where hydrogen costs are optimized not just for the station, but for the entire supply chain. So production, delivery, hydrogen stations, and we model the whole country or different parts of the country out to, say, 2050. So a full range of scenario outputs. When we layer in finances on top of this, you can see how the number of variables becomes very daunting in terms of a user interface to explore, and that's why we're bringing in this multivariate approach. The center graph just shows one example of a particular metric for multiple states. You can also do individual cities or clusters of stations. And then just in the bottom right is one example of a cash flow that you can explore different regions, geographic areas. So that's sort of the problem, is there's a large amount of data in terms of results for particular scenario study. And so that's what this version of H2Fast is intended to try and provide in a digestible format for end users. Let's go to the next slide and we can see the interface itself. It's a map-based interface. So here, just quickly, this is color coding of urban areas as the unit of geographic analysis. You could also do regions or states. But if you click on one of these areas, it'll pull up the metrics for that urban area. And just for people who want to learn a little bit more about this, at the bottom, there's a link for a YouTube video. If you copy and paste that URL into a website or a browser, it'll bring you to that video, and it's just a demonstration of how to use this tool in a little bit more detail. If we click one more time, we can highlight some of the parts of this tool. This is a graphical user interface, and you would launch the visualization tool from this to pull up a particular scenario, set of scenario results. So in the bottom left, you can see that there's a drop-down menu for different scenarios. So in this example, we have this hydrogen success scenario, which is taken from a National Academy study. And we're showing hydrogen demand, which is the color coding for all the different urban areas. The slider in the very bottom left there, you can move between the years to pull up the changes in that particular metric. If we click one more time, we can see in this case the user has clicked on Boston and has pulled up a particular metric for Boston. And the slider is moved all the way to the right up to 2050. So you see the dashed yellow line that shows the value for 2050. If you hover over those other points, you can pull up the numbers for that metric for any other year for Boston. If we click one more time, shows how if you want to explore other metrics, there's a drop-down menu, that new fuel cell vehicle sales button, and you can pull up any of the other metrics. So the idea here is if we loaded financial results for a particular scenario, you can pull up any of those financial trends that we discussed earlier, visualize them with a graph, and then even show some of them side by side. Okay, so that's a rundown of the third version of H2Fast. So in summary, the web spreadsheet tools are available to the public. The spreadsheet can be downloaded from the H2Fast website. If you want to find the H2Fast website, it's easy. Just type H2Fast into Google. It should bring you right to it. And again, currently there's an NREL version of this and an H2USA website that has the same tool. They're identical. The idea behind the web-based version of H2Fast is it's a simple first-cut analysis for hydrogen stations, while the spreadsheet version allows more detailed control of the inputs and more elaborate analysis and outputs. For broader scenario results, the H2Fast framework can also be applied across the full supply chain for hydrogen to look at financing, and that can be done at the city, region, or national levels. So that's the business case scenario tool that we looked at, is the map-based interface. Currently, this tool is just being used internally for H2USA members to look at different scenarios and the financial implications of them. Beta version has been developed. That's the online YouTube video, and we're exploring different ways to make that a useful tool to make available to the general public. So that's all I have, and I'll turn it back to you, Fred.
Okay, thank you, Mark. So now we'll go to the questions that have been raised during the course of the webinar. First, Amgad, this is for you. The question was that if you could give the URL for the model again and kind of identify, you went fast over the slide, so the information's being requested to give the URL again.
Yes, it is under www.hydrogen.energy.gov/H2A_delivery.htm, and if you Google H2A or Google DOE H2A, it will just take you directly there.
Okay, thank you, Amgad. Next question was, have you considered on-site production for hydrogen source? I believe this was for Mark.
Yes, so there are multiple models that have looked at the costs associated with on-site production. So the Google search that Amgad just mentioned will take you to the H2A models that include estimates for on-site stations, for on-site generation. Again, H2Fast itself is not a cost estimation tool, so you would want to estimate the costs from somewhere else, from a real project or for one of the H2A models, and then plug those into H2Fast if you were interested in looking at the finances associated with that particular station.
Amgad, I'll let you answer that as well. So from the HRSAM version.
Yes, this is a good question. So currently, we do not model that for an early station. This will be an additional capital cost that will need to be embedded in the model. Maybe in the future, in a future revision, and with direction from DOE, we can incorporate that for early stations.
Okay, thank you, Amgad. Next question, I believe this goes for to Mark, about are there similar models for LNG, CNG, and stations that provide both liquid hydrogen and I guess CH2, which would be cold hydrogen plus LNG/CNG?
So currently we do not have a comparable model for the other alternative fuels. So we are actually working on that internally, but we don't have a version online. The other hydrogen stations they can be entered as different types within the H2Fast calculator. As long as the user has the right cost inputs, the tool itself will show the financial implications for that particular project, as long as you understand how that, say, liquid hydrogen station or other types of configurations, how that translates into the same inputs. You can use H2Fast. I think that answered the question.
Okay, thanks, Mark. Also, God, that could apply back to HRSAM as well. Do you have an answer for that?
Yes, and currently under development is NGSAM, which is very similar to what you have seen but for natural gas, and this is something guided by FCTO and VTO.
Okay, when you say FCTO, that's the Fuel Cell Technologies Office, and VTO is the Vehicle Technologies Office.
This is correct. So basically, the Vehicle Technologies Office is leveraging really the project from the FCTO and trying to develop something similar with minimum actually effort. So this should be out in the late summer time frame.
Okay. Okay, thank you. Next question was for as far as God with the utilization rates. The question was, what are the typical values for utilization?
So this is a good question. So this utilization scenario is directly from the H2 first report, the report I referenced during my talk. This report is available online, looking at California, different scenarios and depicting a typical ramp-up utilization. This is an input in the model. It is just showing how impactful is that parameter. The user can look at different scenarios. Of course, we know actually stations, if we understand how many stations will be deployed over the years and the capacity, this will tell us the capacity. And as we look at different scenarios of vehicle deployment, between these two, you can develop different utilization scenarios, input that into the model, and see the impact of that parameter.
Okay. Okay, and this question could apply to both Mark and Amgad, so I'll let Amgad you answer first, and then followed by Mark. It says, can these tools be used for in-house stations for fleets, for example, utility vehicles?
Yes, it does. In fact, if you look at the high end, when we look at the station capacity and look at the cost, we saw the economies of scale. Larger stations will be very economical for fleet operation, where you have the demand, you could size your equipment, you have the utilization, and then you will have a much more favorable cost of hydrogen when you handle fleets. So in the model, basically what will need to be done, instead of specifying, let us say, 5 kilograms in 3 minutes, let us say if it is a bus, then you will do, let us say, whatever 30 or whatever kilograms in 15 minutes or so, and then you would pick the 350 bar instead of the 700 bar. And so you could really tweak the demand. The demand profile is a user input, the utilization is a user input, the station size is a user input, and then the fill dynamics and the capacity of the tank, all of these are just the parameters in the model. And of course, even the capital, every single assumption is just an input in the model that the user can change. So yes, it does really. It can apply to fleets, it could apply to even a different vehicle, a different refueling pressure, and even perhaps for, I would take that back. I don't want to say the forklift, because the forklift operation has different metrics, so I will leave it there.
Okay, Mark?
Yes, so fleet managers are definitely one of the end users we had in mind for the H2Fast tool. In general, H2Fast focuses on financial results, but we wanted to design it to be useful for any stakeholders who are involved in a hydrogen station project or set of projects. So as Amgad mentioned, being able to control utilization and seeing how your particular fleet might play into that is definitely one of the sort of analysis capabilities that we wanted to provide.
Okay, thank you. Next question, this would go to Amgad, and it says, appears that you have $14 per kilogram hydrogen at low utilization to $9 per kilogram after 7 years using a smaller station. Have you ever evaluated larger stations?
Yes, actually, and I would say this was just an example to highlight the impact of the utilization, but yes, you are right, and I should mention also that these 9 or 14 are only the station contribution, so on top of that should be the cost of the delivered molecule to the station, so it will be, the bottom line will be higher than that. But as you move to a larger station, of course, it is tricky, because when you move to a larger station, then suddenly you will gain the economies of scale, but you will lose on the utilization, because now I have more capital and less demand. So your utilization curve will be more pessimistic, and then there will be really some insight there whether really a larger station will make sense. So what we see is that larger stations do not make sense with low utilization, because the low utilization will overwhelm the economies of scale. But the model will allow you to look at this and that, and every figure we presented in the slides did assume full utilization. So when we showed the economies of scale and the costs will come down as the stations get with larger capacities, this is assuming full utilization. But now suddenly, if I look at California today and say, well, instead of having 60 stations, I will have 5 large ones. Actually, can that serve the customer? If this is the case, yeah, you will gain the economies of scale because I will consolidate the stations, but this is very unlikely. But if you maintain the number of stations and make them bigger, then actually the hit from underutilization will be very dramatic. So I hope I answered the question.
Okay. Next question is between Mark and Amgad. It says, the question was, are HRSAM, H2Fast tools designed to be linked where HRSAM is an input to H2Fast?
I think I can address that one, Fred.
Okay.
So they're not intended to be linked, but when you open H2Fast, first the default values that are pre-populated into the web-based tool, the Excel tool, are taken from HRSAM. So to that extent, they're linked, but there's no other integration.
Okay. Okay. Next question for HRFast: can multiple production technologies such as methanol, CNG, electrolysis, and liquid hydrogen be evaluated?
I think the answer is yes, they can be evaluated. We have not included them in this particular tool set, but it's relatively straightforward to understand the cost estimation methods and the financial implications for those others, and to put them on a similar basis. So that work has been done by DOE, and there's various different studies that have done that to try and show sort of apples to apples comparisons between these different fuel types. And if the person asking the question is interested, they could email me or Amgad to get access to those.
Okay. For Mark, is Hydra based on current station deployment and fuel cell electric vehicle adoption rates, or is it based on the best case expected station deployment and fuel cell electric vehicle adoption rate?
Yes, I think that might be a complicated question. I feel like Amgad has sort of addressed it in referencing the utilization rate and the source for that in the reference station report. So for the material I presented, H2Fast is not trying to answer that question. It is just a tool that a user can use if they already have good cost estimates and utilization rates for a particular project. I don't know, Amgad, if you want to add anything to that.
I have nothing to add. What you mentioned is sufficient. So you are right. So it is a very difficult question, because in a given market you wanted to initially deploy some seed stations, get good coverage, good distribution, and these have to be small stations initially to minimize the impact of the utilization. But as you build up and how you move from these to larger stations, this is a transition analysis that we have not really conducted, so this will be a good thing to think about in the future.
Okay. Again, for Amgad, how can on-site production of hydrogen through electrolysis be modeled with HRSAM?
So one simple way, it is tricky, but I will tell you one simple way is just to go to the capital cost table and just add a capital for the electrolyzer plus water treatment, whatever. If you lump these, just lump them to any of the components, perhaps a compressor or the pre-cooling, or even actually. So if you do that, then automatically it will propagate through the cash flow tables. But you wanted to pick a component that has a similar lifetime, so that really the replacement rate and everything will fall into place. And if you do that, then you will get something very reasonable. I should mention, however, for on-site production, your storage requirement could be different from delivered case, and the impact of that will be small, but you may want to adjust the on-site storage to account for on-site production, and that no delivery really is coming to the station, so that if you have a downtime, you have enough storage as a backup.
Okay. For Mark, does the model reflect demand supplied by domestic/local/residential supply?
I'm not sure if I totally understand the question, but I think in general it's agnostic, and it's really depends on the project that people have in mind. So I guess I would say it doesn't take that into account, and it would be the end user would have to have an understanding of that to put those values in correctly.
Okay. Question comes, I believe this is for Mark, is how does $14 a kilogram compare to today's fossil fuel prices such as natural gas, gasoline, diesel?
Yeah, so that's a good question. So in general, as a rule of thumb, to get sort of a rough comparison, we would assume that a fuel cell vehicle would be at least twice as efficient as today's conventional gasoline vehicles. So if you wanted to compare it on a service basis per mile driven, you would want to divide that by 2, or whatever the ratio is for the relative fuel economy compared to today's vehicles. So say if it's 14 and you know that the vehicle is twice as efficient, per gallon gasoline equivalent sort of value, or per mile driven, that would be $7 per gallon. And then the $10 per kilogram would be down to $5 per gallon. So that's a rule of thumb, and you really just have to think about the fuel economy of the vehicles.
Okay. Okay. Next question between Amgad and Mark would be any idea of how much land would be required for a hydrogen station?
Yeah, we do calculate that based on the feedback distances in the current code for liquid and the gaseous. Actually, the model will give, I didn't show an example, but the model will give an estimate of the land area requirement.
Okay. For Mark, what input into the financial model was provided by those engaged in the existing fuel industry, fuel retailers, and marketers selling gasoline, diesel, and other fuels in the market today?
Yeah, so that's a good question. Again, the default values that are pre-populated into the model are taken from the HRSAM cost analysis and the report that Amgad's mentioned a couple times. Other than that, the way that we've designed the models themselves is to try and be useful to those types of user groups. And so we wanted to have things that would be familiar to a retail station owner, a fuel supplier, so that they have that information available to them. But the inputs themselves are really taken from the HRSAM defaults. So I hope that answers the question.
Okay. And there's a question that would maybe apply to both Amgad and Mark, and it says, assume these stations are for commercial vehicles fueling medium-duty, heavy-duty trucks. Would it apply to consumer vehicles?
I did not understand the question.
The person seems to be asking, they assume that these stations are for commercial vehicle fueling, such as medium-duty and heavy-duty trucks. Would it apply to consumer vehicles, in other words, light-duty vehicles?
Actually, the model is built for light-duty vehicles, but as I mentioned earlier, we have a 350 bar, 700 bar feature, so it could really work for a heavy-duty vehicle. In this case, it will be a bus fleet, for example, or some fleets. The model will be adaptable to that as long as you are either 350 bar or 700 bar fueling. The model will be able to adjust and give good estimates. But the model is built really for light-duty vehicles.
Okay. Mark, any comment?
I think that Amgad has the right answer there, and I would say that if you do understand the requirements for medium heavy duty, and you have a cost estimate for that station, you could then take those cost estimate results and still use them in H2Fast to understand the finances.
Okay. Next question was, are there stations in commercial operation today? Were the learnings from these stations and data used in the modeling? Mark and Amgad?
I would say to some extent, yes. So as you have seen, the output of the models are, very capital driven. However, certain pieces are not embedded. For example, replacement for certain components. For example, the downtime for equipment. So there are certain features that are not captured there, but by and large, really, the bottom line cost is capital driven. More than 75% of the cost will be just the capital, and the capital is based on today's cost of equipment and installation cost in the field. So this is captured well. So I would say 75% of it is captured very accurately. The remaining 25% is captured to some extent, but not at the same level.
Yeah, and I guess I would add to that on the real world aspect of this, we really need to get more data on especially the stations being put in by the California Energy Commission in California to see how that network evolves over time to understand the real world situation. But as Amgad mentioned, the CEC capital cost estimates from the ponds were the reference for those costs in HRSAM.
Okay. For the one question that was, are the models? Okay, go ahead.
We're going to have to wrap it up here shortly. Maybe you have time for one more question, and
okay.
We'll be ready to wrap it up.
Okay, and are these models adaptable to mobile refueler concepts? This concept is being utilized in Japan.
For H2Fast, yeah, that if you put in the cost the right way, you would be able to assess the finances for that particular type of station. I
would say to some extent, yes. Outside really the cost of packaging and having a container, yes. I should mention that mobile refuelers have much low performance metrics. For example, how many back-to-back they could satisfy and all of that. So they may be just a somewhat different type of station, but they can be modeled with these tools.
Okay. Chris, I'll give it back to you as far as, I know there are a few questions we didn't get to, and you may want to comment on that.
Appreciate it, Fred, and thank you to our speakers and everyone that joined in today. That is going to conclude the webinar. If we didn't get to your question, please feel free to email the presenter directly on the contact information you see there. And they will try to respond in a timely manner. Again, I'd like to thank everyone for joining in. Remind you that the webinar and slides will be available online at the website below in about 10 days. Also, I encourage everyone to sign up for our monthly newsletter, which includes upcoming webinars. You can sign up for that on our website as well. Have a great week, everyone. Goodbye.
Thank you.
Thanks.
Thank you.